Paper 1R, June 2016, question 13. So this diagram shows you some apparatus that is being used to investigate what happens to a current carrying conductor in a magnetic field. So the fact that you have a current in a magnetic field should make you think of the motor effect. So we're putting a current in and it's interacting with the magnetic field. So we are going to get some movement and some force out again. So it says the student connects two parallel horizontal metal rails to positive and negative terminals of a power supply. So you've got a power supply of some kind over here, and it's forming a loop with this metal rod AB. So you've got a complete loop here. So you have a circuit. So you've got current flowing through this metal rod A and B. So it said explain what happens to the metal rod A and B. Okay, so it's the motor effect. So the chances are it's going to move, but we just need a bit more detail about which way it's going to move. Now, if anything to do with the motor effect, you can figure out the direction of the force from Fleming's left-hand rule. Now, for this question, it's 4 marks, and it wants you to explain what happens to metal rod. Now, if you look at the mark scheme, you actually get a mark just for saying that it moves, that A and B is going to move, for realizing that it's the motor effect. You don't have to get the direction correct. You do have to get that it's either left or right, but you can kind of figure that out, and I'll explain how. So the first mark is for realizing that there is a current that is flowing through rod AB. So current in the metal rod. The second mark, which lots of people always forget, is that if you have a current going through a conductor, that means that there is automatically a magnetic field around that conductor. In this case, it's going to be around the metal rod. So you end up with 2 magnetic fields. You have the one that's caused by this row of magnets, and you also have the magnetic field that's going round A and B. So you've got 2 magnetic fields, and they interact. And that's the whole basis of the motor effect, that you have 2 rival magnetic fields, if you like, that then interact with each other. And this interaction produces a force. So even before you've got to thinking about Fleming's left-hand rule or working out any kind of direction, you've already got 4 marks. So if that's all you wrote, that would be perfect. The 5th mark is for mentioning the fact that it's the actual motor effect, so naming the motor effect or mentioning the left-hand rule. And then mark number 6 is for working out which direction it would move. So it's not essential. Now, with Fleming's left-hand rule, it's force, field, current. So your force is the thumb, your field is your pointy finger, and your current is your middle finger. But you have to be careful because the current is the conventional current. So it's that imaginary current that we have that's in the opposite direction to the way the electrons are going. So in this circuit, the electrons will be going that way because they're going from negative to positive. So that means that for conventional current, it's actually flowing that way through the circuit, which means it's going that way through the rod. If you wanted to work out which direction the magnetic field is going, magnetic field always goes from north to south. So in this case, because the north poles are facing up, your magnetic field will be coming out of the paper. And if you use Fleming's left-hand rule, so your magnetic field is out of the page, your current is going up, if you like, and that would mean that your force is going to move that way to the right. But that's hard to figure out. Just stating that it's going to move is going to be a lot easier, and having a guess at whether it might be left or right. So for the next part, we've got a loudspeaker. You again have this time a circular magnetic field, and you've got a coil of wire that a current is going to flow through. And in this case, it's going to be an alternating current. And it says, describe how the alternating current generates a sound wave. Now, if this was direct current, what would happen is the current would flow through the wire. There would be a magnetic field generated around the wire. And those two magnetic fields would interfere, the one from the wire and the one from the magnet. And you would get a force that would push the coil either in or out. It doesn't really matter at this point. You can work it out, but you don't have to for this question. But alternating current is the one where it continually changes direction. So for direct current, it would produce a force in one direction, but for alternating, it's going to produce an alternating force that is constantly also changing direction. And in this case, in and out. So the way that the coil is wrapped around the magnet and the shape of the magnet mean that your forces end up pushing in and out. So the paper tube is connected to the coil, which means that as the coil moves backwards and forwards, as the coil vibrates, the paper tube is also going to vibrate, and it's going to collide with the air particles, and it's going to create a sound wave and pass the energy on. So for 4 marks, you've got about 6 marking points that you could possibly have, and you only need to get 4 of them. We mentioned the alternating current here. So alternating current, let's have a description of that. So alternating current continuously changes direction. Okay, so that'd be 1 point. Another point that leads on from that is, therefore, you have a changing or alternating magnetic field around the coil. Number 3, just like in the first part, you could have that the two magnetic fields now interact, the changing magnetic field around the coil and the magnetic field from the actual magnet. Then you could also have that this produces a force that changes direction as well. And you've got your 4 marks already. That would actually, for this one, they're quite generous in the mark scheme, that would actually be worth 2 marks. One for producing the force and the other one that changes direction continuously. I think that word's important. And then number 6 is what I was saying here about colliding with the air particles and producing a sound wave.